Hello everyone, welcome to tutorial number 11 in database CSEN 501. In this tutorial, we will dig deep into the normal forms and discuss the first normal form, the second one, and the third one, and the bias code normal form. And we are going to solve some examples to understand the normal forms more. Okay. The normal form, the first normal form, stated that if the domain of all attributes of the R are atomic. When we can decide whether this schema in the first normal form or not, if the domain of all its attributes are atomic, which means that every attribute is a single valued, no 2D table. In other words, if the table is something like this, name, SSN, phone number, for example, and for each name we have only one phone number. Okay, if it happens that we have a name with array of phone numbers where this attribute is not atomic, it is not a single value, then this relation is not in the first normal form. So a relation is in the first normal form if the domain of all attributes are atomic, which means that they are single valued. Let's move to the second normal form. If every non-prime attribute is fully functional dependent on the primary key. What does this mean? Let's assume that we have a relation schema, employee, SSN, name, department, project, salary. And the primary key in this case is SSN plus the name. This relation in the second normal form, if every non-prime attribute, which is an attribute that is not part of a candidate key, is fully functional dependent on the primary key, which means that no attribute is dependent on a subset of this key. For example, we cannot have an attribute dependent on part of the primary key. So, if a relation has a primary key of one attribute only, then definitely this one is in the second normal form. When to start to ask whether this relation is in the second normal form or not? Whenever a relation has a composite key, has a primary key that consists of more than one attribute. Okay. The solution for each case is always decomposing. So in this case, if we have name, a department dependent on name, okay, we are going to remove department from this relation and make a new relation with name, department, and remove department from here. So that in each relation, each non-prime attribute is fully functional dependent on the primary key. Okay, and the same goes for the first normal form. In this case, we are going to take the name and phone together in the new relation, and both will be the primary key, so that the phones will be each value in a row. Okay, the same as the multi-valued attribute when we map a multi-valued attribute. Let's move to the third normal form. When a relation is in a third normal form, if whenever a non-trivial dependency X implies A holds in R, either X is a super key or A is a prime attribute. Actually, we know if we are in the third normal form or not if there is no transitive dependencies. Let's know what is the meaning of transitive dependency. Assume that we have table student with student ID, email, grades, semester. And the primary key is the SID. Since the primary key is the SID, so we can get the other attributes from this primary key, which means that SID implies all other attributes. What if we have another dependency where from the email of the student, we can get the semester of each student? Okay? Now, here we have a transitive dependency. What is a transitive dependency? Actually, we can get the semester from two ways. Either from the SID, we can get the semester, or from the SID, we can get the email, and from the email, we can get the semester. So this is a direct way and this is an indirect way. This indirect way is called a transitive dependency. So a relation is not in the third normal form if we have a transitive dependency. Why? Because in this case, we have a dependency where X is not a super key because it's not part of any candidate key, and Y is not a prime attribute because it is not a part of the candidate key. So neither A can be used as a candidate key, neither X is a super key, nor A is a prime attribute. So in this case, we have a dependency which violates these two conditions. So in this case, we are not in the third normal form. Okay? Whenever we found any transitive dependency, you should conclude that this one is not in the third normal form. And the solution is to decompose and remove this transitive dependency in a new table so that we can remove semester from here and we can get semester from a new table called R1, for example, having the mail and the semester, where the email is the primary key. Okay? The last type of the normal forms is the bisecond. It is the same as the third normal form. However, whenever we found a dependency, it holds only when X is a super key. Okay? So it is the same as the third normal form by removing the second condition. Okay? Let's take an example. Assume that here both are a primary key. Okay? And we have a relation that grades, for example, implies email. Okay? This relation will be in the third normal form because email is a prime attribute because it's a part of the primary key. However, in this case, this one is not in the bisecond normal form because in order for a relation to be in the bisecond normal form, every dependency X should be a super key. Is grade a super key? No. So in this case, the relation will be in the third but not in bisecond normal form. Know that the normal forms are something like this: first, second, third, which means that whenever a relation is in the third normal form, it will be automatically in the second one and in the first one. If a relation in the second normal form, it should be in the first normal form as well. Okay? Let's take an example. Consider the following relations that store info about projects in large business and set of functional dependencies. The relation is called work. We have project name, project manager, employee ID, hours, name, budget, start date, salary, employee manager, department rating. Project name implies manager, budget, start date. So if we have the project name, we can get the manager, the budget, and the start date. Employee ID implies employee name, salary, manager, department. So if we have the employee ID, we can get the name, the salary, the manager, and the department. Together, the project name and the employee ID can get the hours and the rating. So, before completing, what is the primary key in this relation? What are the attributes that if we have, we can deduce all other attributes? Actually, the project name and the employee ID. Okay, because the name can get these attributes and the employee ID can get these, and together can get the hours and the rating. So the primary key in this case is the project name and hours. And the employee ID. Okay, let's move forward. The employee department can get the manager. So from the department, we can deduce the manager. Normalize the above relation up to the third normal form. If it is not stated that we have an attribute with multi-valued data or with 2D array, then this one is automatically in the first normal form. In order to normalize to the third, we should go step by step. First, normalize to the first, second, and then to the third. Since in this example, it is not stated that any attribute is of type array or something, then this is by default in the first normal form. Let's check whether this relation is in the second normal form or not. The second normal form stated that the relation is in the second normal form if every non-prime attribute is fully functional dependent on the primary key, which means that no non-prime attribute is dependent on a subset of the primary key. Let's check it. These are the non-prime attribute. Okay? Is any one of them is dependent on a subset? Actually, yes. Because the name, the salary, the manager, the department dependent on a subset, which is the employee ID. And also here, the manager, budget, start date depend on a subset, which is the project name. So this one is not in the second normal form. In order to do so, we should decompose so that we will have a relation 1 with project name and the attributes that are dependent on the project name, which is the project manager, budget, start date. R2, employee ID with the employee name, salary, manager, and department. Right, this is the primary key and this is the primary key. And then we will have a relation with the primary key of the original one, which is the project name, the employee ID with the remaining attributes, which are hours and rate. Now this is the new relations. These are in the second normal form. Okay? Let's check whether these relations are in the third or not. Do we have any transitive dependency here such that we have any attribute that implies another attribute? Actually, no. All these can be deduced only from the project name. Let's check here. Do we have here any dependencies except that employee ID implies all? Actually, yes. We have employee department implies employee manager. We have here the department implied the manager, such that we can get the manager directly from the employee ID, or from the employee ID we can get the department, and then from the department we can get the manager. So R2 is not in the third normal form. In order to be in the third normal form, we should decompose more. So R2 will be decomposed into two more relations to be in the third normal form. R2 will be employee ID, employee name, salary, department, and we will have an extra one with department and manager. Okay, so this one will be replaced by these two. Do we have here any transitive dependency? Can we get ours from anything except these two? No. Rating? No. So now the new four relations are in the third normal form. Let's take another example. Provide a lossless join decomposition of S into the B, C, and F. Okay, let's normalize to the third normal form and then check the B, C, and F. Okay, now A implies A, B, C, D, E, F, which means that the A is the primary key. C, D implies E, so if we have C and D together, we can get the E. F implies B. Since no attribute is multivalued, so this one is in the first normal form. Let's check whether it is in the second or not. Actually, this relation has a primary key of one attribute, which means that definitely this one is in the second normal form, because no attribute is partially dependent on the primary key, because the primary key is only one attribute. So definitely all of them are fully functional dependent on the primary key. Now let's check whether we have any transitive dependency or not. Okay? From A, we can get C and D. And from C and D, we can get E, which means that this is a transitive dependency. Okay? And from A, we can get F. From F, we can get B. So this is a transitive dependency as well. So in order to reach the third normal form, we should remove these dependency and put it in new table. So we will have S1 with F and B, S2 with C, D, E, and S3 with the remaining A, C, D, F. Okay? Now we want to check whether we are in the B, C, and F or not. In order to do so, we must check in each relation that there is no dependency, X implies Y, where X is not a super key. In this one, F implies B and F is a super key, so this one is in the B, C, and F. In this one, C, D together implies E. No other dependencies here, so this one is B, C, and F. In the last one, we cannot deduce the C except from the A, D, F, so this one is in the B, C, and F. Which one of these dependency was the one making this relation not in the B, C, and F? Actually, the two, because it happened that we have two dependency where the left-hand side is not a super key. However, when we decomposed them into two relations, making them a primary key, then they change it into super key. So now the three relations are in B, C, and F. Okay? Consider the following relation. Given the following set of functional dependency, what is the primary key of R? Is the relation in the third normal form or not? If yes, explain why. If not, convert it. Okay, if we have the C and E together, we can get the A. If we have the D, we can get B and C. If we have the C, we can get the D. If we have the E, we can get the B. In order to get or extract the primary key easily, we can check the right hand side. The A can be deduced. The B and C can be deduced. The D can be deduced. The B can be deduced. So the only one that cannot be deduced is the E, right? However, if we make the E primary key, can we deduce the other? No. Okay? The only option is to get the A is through C and E. So let's check if we make the C and E primary key. From the E alone, we can get the B. From the E, C, E together, we can get A. Now we have A, B. From the C, we can get D. So actually from CE, we can get all the other. So CE can be the primary key in this case. So in this case, T, A, B, C, D, E. The primary key is C and E. Okay? This relation is in the first normal form. Let's check whether it is in the second one or not. Do we have any dependency that is dependent on a subset of the primary key? In another word, is there any attributes dependent on the C alone or the E alone? Actually, yes. The B is dependent on the E alone. And the B can be deduced from the E, and the D can be deduced from the C. So this one is partially dependent on CE because it's fully dependent on E, and this one is fully dependent on C. In order to make it in the second normal form, we should decompose it. So we will have T1 with E and B, T2 with C and D, and T3 with the remaining C, E, A. Now let's check. Definitely this one in the second and this one in the second because the primary key is one attribute. Now, can we deduce the A from subset of the CE from E alone or C alone? Actually, no. So this one is in the second as well. After decomposing, let's check whether we are in the third or not. Do we have here any transitive dependency? Actually, no. The B can be deduced from E only. D can be deduced from C only. And here A can be deduced from 2 only. So the 3 are in the third normal form. Okay? Let's move to another example. Examine the relations shown below and for each one, choose the correct answer. You need to state all the functional dependencies in each one. In case it's not in the third normal form, describe and illustrate the process. Okay, let's take a look here. Shop number, shop address, phone number. In order to check whether it is in the third normal form or not, we have to move it step by step. First, check the first and then the second. To check the first, we need to make sure that each attribute is a single valid. However, in this case, the phone number is a multi-valid because in one row, we can have more than one value. So in this case, this one is not in the first normal form. Okay? How to make it in the first normal form? We can take the primary key, which is the shop number, R1, with the phone number in a relation, making them together a primary key. And R2 with the shop number and the shop address. Let's check after decomposing whether we are in the second or not. Actually, we are in the second because this relation is composed of a candidate key only. And this one is in the second because the primary key is of one attribute only. In this one, no transitive dependency is the same here. So now, both of them are in the third normal form. Let's move to another example. Let's check this relation. Each attribute is a single valid, so this one is in the first normal form. We want to check whether it is in the second or not. In order to do so, first we need to get the dependencies from this table. Okay? Whenever the SID is 30019, we will find that the employee name will be the same. Which means that the SID implies the employee name only. The contract number, when it is 25 here, the company ID and the location are the same. And when it is 26, the company ID and the location are the same, which means that the contract number implies the company ID and the company location. Okay? Now, in order to deduce the hours, we must use the both together. So in this case, the primary key of this relation is the SID and the contract number. Together we'll get the hours. Okay, if this relation is the second normal form, yes or no? Actually no, because we have attributes that is dependent on a subset of the primary key. We need to normalize it, so first we will have R1 with SID and employee name, R2 with contract number, company ID, company location, and R3 with SID, contract number, hours. So before decomposing, this relation was in the first but not in the second. Okay? Now we decomposed in the second to the second normal form. Let's check whether we are in the second normal form or not. Actually, this relation is the primary key is one attribute only, so this one is in the second normal form. This one is in the second normal form, and here hours depend on both of them. Are we is each relation is in the third? Here we don't have any transitive dependency, but let's check this relation. Okay, if we check the table, one will think that whenever I have a company ID, the location will be the same, which means that company ID can get the company location. So in this case, if this is the case, we can get the location either from contract number, or from contract number we can get the company ID, and from company ID we get the company location. So in this case, to be in the third, we should decompose this into two other relations: contract number, company ID, and company ID with the location. And last but not least, this one is in the third because we only have one attribute that can be accessed from these two relations. Let's take the last example. This table, let's first deduce the primary key when the staff number is repeated, so it cannot be a primary key alone. Let's check whenever it's repeated which attributes changes. So whenever it is 5 as for 555, the name will be the same and the position will be the same. And whenever it's 12, it will be the same here and here, which means that staff number implies name and position. Okay, so first, this relation is in the first but not in the second. We are going to check it. The branch number, whenever it's changed, the branch address changes as well. So branch number implies the branch address. The hours per week can be deduced from both of them together because both will form a unique attribute together. So in this case, staff number and branch number can get the hours. Why we are not in the second normal form? Because if these are the primary keys, because if we have both, we can get all other attributes. We have some attribute that is not fully functional dependent on them because name and position is dependent on a subset. Branch address is dependent on a subset. And that's why this one is not in the second normal form. So we need to decompose, making this in a relation, and this one in a relation, and the third one in a relation. That was it for today. Thank you very much and see you next time.